Mushrooms are found all over the world. They are nutritious and good for you. They taste good, although some may beg to differ. And many mushroom species are edible. Today we're going to be talking about a species that is not edible and is in fact very deadly, the death cap mushroom. So let's go through some general facts. So this mushroom is called Amanita phalloides. I believe that's how it's pronounced. This genus Amanita includes some of the most deadly mushrooms on the planet. These mushrooms are found all over Europe, Australia, and many other places. Recently, a woman in this town in Australia called Leongatha most likely poisoned a bunch of people she made food for, and that food she made had these mushrooms in it, which is where I really got the inspiration for this video. So these mushrooms have similar looks to other edible mushrooms, and this actually accounts for 95% of the accidental poisonings. This is the research that I saw. This seems to be just from foraging. You're not going to find these just being sold in a grocery store. These can be found growing under oak trees, at least in Australia. One of these can kill an adult-sized human. The specifics of the damage is liver and kidney damage. We're going to be talking about that in this video. Another interesting piece is that no amount of cooking, drying, peeling, or soaking will make it edible. The molecule or compound in this mushroom cannot be destroyed. So what is that compound? That compound is something called alpha-amanitin. There are other compounds that produce the toxic effect, but this is the main one. This molecule is a part of a group, a family called the amatoxins. Now, these toxins are present in all sorts of mushrooms. Notably, they are present in the destroying angel mushroom and the mushroom Amanita muscaria, which is this one right here. It's a famous looking one. It's beautiful, but very deadly. Right here is alpha-amanitin. It's a really interesting three-dimensional structure. Here is a modeling of that same molecule. This is a cyclic peptide of about 8 amino acids. Now, how does it work? It inhibits this structure called RNA polymerase II. We're going to be talking about what that is in a few minutes. This leads to severe liver and kidney damage, specifically liver cell death, and from what I saw, death occurs usually within a week. It can be difficult to diagnose because unless ingestion details are known, it can be hard to figure out what's really going on. A lot of these effects are very delayed. Although this is true, this toxin can be readily identified, especially if poisoning is suspected. Let's dive deeper into how it actually works. So this molecule has a specific affinity or attraction to RNA polymerase II. So what is RNA polymerase II? Those of you who know biology are getting terrible flashbacks, you can fast forward if you know what this is. So in general, the goal for our body, the goal for vast majority of life is to make proteins, and they do this through this process called transcription and translation. I won't bore you with all the specifics, but we're going to really talk about RNA polymerase II at a very, very general term. So we take DNA, and DNA is used to make RNA, and RNA is used to make proteins. Well, why are proteins important? Proteins are used for things like transporting different structures through the body, muscle contractions and movements, hormones or proteins, antibodies, the immune system, cellular structures. Proteins make up almost everything, and they are incredibly important. So what does RNA polymerase II have to do with this? So in the goal of this process to make proteins, you need to take DNA. So we're over here with the transcription section. We need DNA, and we need to turn that DNA into RNA. RNA polymerase II, this structure here, will read the DNA and copy it and make what's called RNA. In this case, messenger RNA. Now, if we go over here, this mRNA, once it gets released, it goes into this structure called the ribosome, and then it makes proteins. And this depends on what it's trying to make and all kinds of specifics. The whole point of this is that alpha-amanitin stops RNA polymerase II from doing an efficient job of copying that DNA. It slows the rate and a bunch of other stuff. The mechanism is not fully understood, but we know some of the most important pieces. Now, this molecule is taken up into the liver, which is really where it does a lot of its damage. Just make this a little bigger. So this activates what's called the tumor necrosis factor alpha. What that does is it leads to hepatocyte death or liver cell death. It leads to neuron death. The toxin also causes something called oxidative stress. Oxidative stress will destroy cells and tissue. It's also responsible for other things like cardiovascular disease, cancer, asthma, and all sorts of stuff. So once someone ingests these mushrooms, what happens? I mentioned before there is a delay in the symptoms. So when you consume these mushrooms, it really depends on the amount of mushroom you consume, the person, the biology of the person. The effects aren't immediate. So within 10 hours, there are effects, and these effects can be things like diarrhea, cramps, vomiting, nausea. What's interesting is that this resolves after about 24 hours, and you might feel fine for up to 72 hours. But then 3 to 6 days after consumption, your liver and kidneys can be they get severely damaged. Death can occur after about a week, and this can be because of liver and kidney failure, coma, respiratory failure, or your lungs in that section of your body stops working. It's a pretty terrible way to die. Now, the current treatments available are things like stomach pumping, which will take out, hopefully, those mushrooms, but this has to be done in a certain amount of time. Getting someone fluids, activated carbon, if it's bad enough, liver transplants, and apparently penicillin also works. But these are not foolproof methods. It really depends on how soon the poisoning is discovered and a whole bunch of other factors. These are just what we have now to help the patient out as much as possible. Okay, one last slide. I found this on a paper in the journal Nature. So let's talk about this really interesting possible treatment for alpha-amanitin poisoning. So we have this really interesting molecule called indocyanine green. Now, what is this? This is a dye that's used to determine things like liver function, heart output, and all sorts of other stuff. It's a diagnostic tool so that doctors can see what's really going on. It's a very, very useful dye. So I mentioned before that the mechanisms for this poison is not fully understood, but certain parts of it are. So that's why we're going to talk about indocyanine green. So in this paper, they identified this pathway, this thing called the N-glycan biosynthesis pathway. What that is, I'm not going to get too deep into it. This possibly allows for this toxin to enter into the cells. Then they identified a part of this pathway. Because what they're trying to do, they're trying to figure out, okay, what part of this pathway can we knock out so that this toxin doesn't work? And through all sorts of experiments, they found this enzyme called STT3B. They found that this is a key part of this pathway. So if they could stop this piece from working, then they might be able to bring down the whole house. Let's think about a game like Jenga or stacking blocks. If you remove a block at a certain place, you might be able to bring down that structure. So what they found through experiments with mice and stuff like that is that ICG, indocyanine green, plus this enzyme, when you dock them or connect them, this can lead to prevention of cell death, significant reduction of liver and kidney damage, and an increased survival rate. The paper was really interesting, a little complicated, but at the end they proposed that this should be considered as a treatment for those who have been poisoned. Now, let's go over here. There's an 8 to 12 hour window post-exposure, so it needs to be used as early as possible. It can't be used late into the progression of the toxin because it's not going to work. The person probably might die. I wanted to bring this up because I thought it was very, very fascinating, and I think it's cool to keep track of and see what progresses from here. So let's go through the summary and review what we learned. So we talked about how this mushroom is a part of a family of some very deadly mushrooms. We can find it all over the place. It's responsible for a lot of accidental poisonings. One can kill an adult-sized human, and the big piece is the liver and kidney damage. You also can't destroy the toxin by cooking or drying it or anything you could try to eliminate the substance. We then talked about the culprit, alpha-amanitin, a part of this family of the amatoxins. It inhibits a structure called RNA polymerase II, which results in severe liver and kidney damage, which can kill a person within a week. It can also be very hard to diagnose the condition. We talked about this RNA polymerase II structure that takes DNA and makes RNA, which then can be used to make proteins, which are useful for all sorts of things in the body. This compound stops that machinery, that RNA polymerase II, from working, which can result in cell death, tissue damage, and all sorts of other things. There's a significant delay in the symptoms. Within 10 hours, you'll start to show symptoms of diarrhea, cramps, vomiting, nausea. They might reduce after about 24 hours, and you might feel good for a few days. And then, by that time, your liver and kidneys are damaged. Death can happen for about a week. It's going to be because of organ failure. There are some treatments for it available, but nothing is set in stone, and a lot of the treatment needs to be done early to stop the progression of the toxin. We then talked about the paper on indocyanine green, this dye used to diagnose different conditions to see the blood flow through things like the heart and the liver. We talked about how this dye can eliminate a key part of this pathway that the toxin uses to enter the cell and cause all sorts of damage. This results in things like prevention of cell death, dramatic reduction in liver and kidney damage, and an increased survival rate. And it was advised to be used early as possible if it is something that ends up being used for treatment. I hope you guys learned a lot from this video. I learned a lot from the research I did. As always, thank you so much for watching and listening. Please like, comment, and subscribe. Tell your friends, and I'll be back soon with another video.